Hey students, this is lesson 9.2, quadratic functions. This lesson we are going to learn how to graph quadratic functions in the form y equals ax squared plus bx plus c. Go ahead and do the review here. I'll check back with you. All right, one thing we're going to find out is that the line of symmetry is an important part of the graph of a quadratic function. It contains the minimum or the maximum. So the vertex is on the line of symmetry. And it turns out that the line of symmetry can be found by, if you have an equation in standard form, then the expression, the opposite of b over 2a, where b is the coefficient of the linear term, a is the coefficient of the squared term, that will give you the x-coordinate of the vertex, or the line of symmetry if we write it like that. So I'll do one example with you, and then you can try the other. So in this equation here, a is 1 because it's 1x squared. B is 3. So we're going to take the opposite of 3 and divide it by 2 times a. So the line of symmetry will be at x equals -3/2, which is also where the minimum or maximum will be. In this case, it will be at minimum. Go ahead and try 7 and 8. You can check back for your answers. All right, so we're going to use that to help us make a graph of a function. In this case, I'm not going to just find a bunch of points. I'm just going to use the line of symmetry and some easier points to find to help me do that. So first thing you're going to want to do when you graph it is find the line of symmetry, because you know the vertex will be on that, and then we'll find the vertex. So find the line of symmetry. And to do that, we have to know that a is equal to 1 because it's 1x squared, and b is equal to -6. And the line of symmetry is x equals the opposite of b divided by 2a, which is -6 divided by 2 times 1, which is 6/2, which is 3. So the line of symmetry is at 3. And I'll go ahead and put that on the graph right now with a dotted line. So right there is my line of symmetry. Okay, now I'm going to find the vertex by using this point. I know the x-coordinate of the vertex is 3 because it's on the line of symmetry. So I'm just going to substitute that into the equation. So instead of x squared minus 6x plus 2, I'm going to do 3 squared minus 6 times 3 plus 2. And that's equal to -7. So my vertex is 3, -7. So I can plot that point now. That's right about there. Okay, now I need another point, and one fairly easy point to get is the value of y when x is 0, which is the y-intercept. So if I find that, what I'm doing is just substituting 0 in for x. So I'm doing 0 squared minus 6 times 0 plus 2. But that, of course, is 0, and that's 0, so it's just y equals 2. So there's going to be a point at 0, 2, which is right about there. And then using the line of symmetry, I'm going to go exactly in the same place, but over to the opposite side that minutes. So at 6, 2 will be another point. Okay? And then I'm just going to find one more point to help me out, and I think I'm going to find the output when the input is -1. So I'm going to do y equals -1 squared minus 6 times -1 plus 2, and that's equal to 1 plus 6, which is 7 plus 2, or 9. And so at -1, I'm at 9, so that's a point there. And then using the line of symmetry, at 7, I would also be at 9. That doesn't quite fit on here, but it's over here somewhere. Should have used a little bit different scale. But I think that's enough information. I'm just going to run my line through those dots. and my graph will look something like that. Go ahead, you try that. All right, in the last lesson we used h equals negative 16t squared plus c to find the height above the ground of an object just falling from initial height c. If an object is projected into the air, the initial velocity v changes the equation a little. So right here, this v is the initial velocity. So we can use this standard form to write an equation for something that has an initial velocity. So here's a problem. Daniel kicks a soccer ball up into the air with an initial velocity of 64 feet per second. The ball is 2 feet above the ground. Okay. How long will it take the ball to reach its maximum height? So we need that. How high above the ground will it be? And what is the range? So we need three things here. So so this function is the function of the height given with an input of the time, so height according to how long it's been kicked. And here it is, right here. So it's negative 16t squared. That's the constant of gravity there. And then plus our velocity times t, and that's 64 here. With that, plus our initial height, so the beginning height, which is 2 feet when it was kicked. Okay, now we want to know, first of all, we want to know its maximum height. The maximum will be on the vertex. So let's find the vertex. Remember, the vertex is on the line of symmetry, which in this case is going to be t equals the opposite of b over 2a. And b is 64, and a is negative 16. So we're going to do negative 64 divided by negative 32, which is 2. So at 2 seconds, it reaches its maximum height. We now know that it's at 2 seconds. So now that I know it's at 2 seconds, I can just substitute that in and find h of 2 seconds, which is negative 16 times 2 squared plus 64 times 2 plus 2, which is 66 feet. Now that's the maximum. So if you can imagine this on a graph, it starts at 2 feet, goes up to a maximum, and then it comes back down. Kind of looks like that. And that's at 2 seconds time when it reaches its maximum. All right. The last thing we want to know is what is the range of the function? Well, since 66 is the maximum, that's as high as it gets. So the range for h will be, the highest it ever gets is 66. So h has to be less than or equal to 66. And the lowest it ever gets is when it hits the ground, which will be 0. Okay, so you could also write it using interval notation. You could just say, use a bracket, 0, 66 for a range. All right, you try that. All right, some of you may be wondering on this problem why the height doesn't go down to 0, and it's because in this one, the information given is that the t-shirt is caught 65 feet above the court, so it never reaches the ground again. So the height can range anywhere from 5 feet where it's kicked up to its maximum, 69. That's the end of the lesson. Go ahead and do the lesson check, and we'll talk about this next time we meet in class.